AI is poised to play a transformative role in NASA's future space exploration missions, becoming a crucial tool for innovation and discovery. Here's a deep dive into how AI is reshaping space exploration and what could come next. 1. Autonomous exploration and navigation. AI systems such as the Autonomous Exploration for Gathering Increased Science, AEGIS, and Enhanced AutoNav are revolutionizing how rovers navigate and conduct scientific research on distant planets. These AI-driven systems enable spacecraft like the Perseverance rover to make real-time decisions, select targets, and navigate challenging terrains without constant human intervention. This autonomy enhances mission efficiency and allows for more extensive exploration. 2. Mission planning and management. AI tools help streamline mission planning, scheduling, and resource allocation. For instance, NASA uses AI to optimize the scheduling of space missions, ensuring that resources are used efficiently and mission objectives are met. AI can analyze vast amounts of data, identify optimal trajectories, and predict potential issues, allowing for better preparation and management of space missions. 3. Environmental monitoring and analysis. AI-powered systems are used to monitor and analyze environmental factors on Earth and in space. NASA leverages AI for tasks such as monitoring volcanic activity, tracking climate changes, and predicting natural disasters. In space, AI can analyze data from satellites and telescopes to identify celestial phenomena, study planetary atmospheres, and detect asteroids or other potential threats. 4. Data management and automation. AI assists in organizing and analyzing the massive amounts of data generated by space missions. NASA's scientific data is tagged and categorized using AI algorithms, making it easier for researchers to access and analyze the information. AI can also automate routine tasks, such as image processing and anomaly detection, freeing up scientists to focus on more complex analyses and discoveries. 5. Aerospace and air traffic control. AI enhances air traffic management by optimizing flight paths, reducing delays, and improving safety. NASA collaborates with the Federal Aviation Administration, FAA, to develop AI-driven systems for air traffic control, leveraging machine learning to predict and manage air traffic more efficiently. These advancements benefit both space missions and commercial aviation, ensuring smoother and safer operations. 6. Robotic assistance and maintenance. AI-powered robots can assist astronauts in space with tasks such as equipment maintenance, repairs, and experiments. Robotic assistants like Robonaut and Astrobee are designed to work alongside humans in space, handling routine or hazardous tasks. This collaboration between AI and astronauts enhances mission productivity and safety. 7. Space habitat management. AI can optimize the management of life support systems, energy usage, and other critical functions within space habitats. By continuously monitoring and adjusting environmental conditions, AI ensures the well-being of astronauts and the efficient use of resources during long-duration missions. 8. Human-AI collaboration. AI serves as a valuable collaborator for scientists and engineers, providing insights, simulations, and recommendations. By analyzing data and running simulations, AI can help researchers design experiments, develop new technologies, and solve complex problems. This collaboration accelerates innovation and enhances the overall success of space missions. As AI technology continues to advance, its role in space exploration will only grow, enabling NASA to achieve new milestones and make groundbreaking discoveries. The integration of AI in space missions enhances efficiency, safety, and scientific output, paving the way for a future where AI and human ingenuity work hand in hand to explore the cosmos.